Hi everyone, my name is Freddy.
I'm Josh,
I'm Alex.
and we are the Semi-Automated Component Tester Capstone Group. Our client, the University of Alberta ECE Kitting Room, rents out electrical test equipment kits to students. Between 50 and 100 kits get handed out per semester. And when all of them come back, they have components inside, such as the Analog Discovery 2, which need to be calibrated before they can be sent back out to students. This can be very time-consuming and tedious, taking on the order of 10 minutes for a single calibration, not to mention the tens, if not 100 calibrations you will need to be doing. To solve this problem, our group developed the Semi-Automated Component Tester Board and its accompanying software suite.
If only there was a better way.
I have just what you need. Well, let me show you this new device, the semi-automated component tester. All it takes is plugging in a few cables.
This'll calibrate my analog discovery?
Of course. And that's all it takes.
That's all it takes? That's everything?
We just need to click a few buttons and you'll have your calibration in no time.
Just a few buttons?
Look at this. Just one button. Just let it do its thing.
This'll save me hours.
Part of the reason that the Analog Discovery 2 is so difficult and time-consuming to calibrate is the many steps that are required. First, I have to open up the calibration wizard and do my linearity calibration. Next, I have 20 different voltages that I need to measure with a multimeter and enter into the software. 0.0021. 1.056. If I were to go through all of these, it would take a lot of time. I think you get the point. After this, we have to rewire the Analog Discovery 2 in a breadboard so that we can calibrate the oscilloscope. The oscilloscope calibration takes some time, as you can see. We'll skip past this also, because after the oscilloscope calibration, there's a second stage where you need to rewire again. After all of this is done, we have to calibrate the positive supply, which again requires me to manually measure and enter these voltages. Overall, this is a very time-consuming process and can take close to 10 minutes for each Analog Discovery 2.
So let me give you an overview of what's going on here right now. So essentially what's happening here is the program is automatically fetching the voltage values from the multimeter and feeding them to the waveforms application. Now, in order to do this, there's three different layers that we have implemented into this system. We have a hardware and also a firmware, and finally also a software layer in order to achieve this. My friend here is gonna talk about the hardware layer with the semi-automated component board.
So, we designed our custom semi-automated component board to help automate the calibration process. We have these relays, which configure the different wiring states that are necessary to calibrate the AD2, which is plugged into this nice zero insertion force socket, which allows for many insertions. This microcontroller is connected via USB-C to the computer, and the computer sends commands through the firmware to control the relay states. And the digital multimeter is plugged into the board on this calibration bus to measure the different voltages that are needed for the calibration. Well, hey, would you look at that? It's already finished calibrating.
So as you can see here, there is no need for human intervention during the calibration process. All it takes is for the end user, to essentially connect the analog discovery 2 or 3 devices to this calibration board, and then they can just press this button here and start the calibration. So essentially with this, we have achieved a fully automated system for calibration, and we've achieved, as you can see here, roughly about 1.5 minutes of calibration time, and thereby we save a lot of time.
The inspiration and basis for our project was this original semi-automated component tester that our client already had. It is able to function, but was undocumented, and it took us some time to reverse engineer how to get it to work. There's also some quality of life issues with it. For example, the power connection is not very user-friendly and not very stable. Wow, look at that. Good timing. I just had another 82 finished calibration. Let me go ahead and get the other one started. So, we went ahead and designed our own new version of the calibration board. This allows us to use more modern interfaces and more user-friendly interfaces for the different plugs that we need, such as our USB-C and a barrel jack. We have an onboard power supply, so you don't need to worry about having a large benchtop power supply, and it's less likely to damage any componentry. Ooh, that's not plugged in. But look at that, it's still working, we're all good. To create our PCB, we had to make a layout design. For this, we used KiCad, and before we could make our layout, we had to make an electrical schematic. You can see here the 5 relays that control the different wiring states, along with our microcontroller that is used to interface between the computer and do the actual controlling. Speaking of our microcontroller, it's based on the Arduino Uno, so the firmware is written using the Arduino framework and is super easy to modify and upload. Additionally, the ECT department plans out these current sources to some of the lower-level undergraduate courses. They get used to learn about the basics of electronics. You know, Ohm's law and all that stuff. That one's working right. So we added in this tester. It's got a few resistors, and the current gets measured by the microcontroller to make sure that they're working properly. That way, if there's any duds, they won't get sent out to students. Oh, guess that one's dead. Hey, look, our calibration finished. All right, let's head on to the next one. You know, these analog discovery 2s, they're great and all, but they are reaching end of life. Pretty soon, actually, I believe already, you won't be able to buy them anymore. Oh my god, look at that! It's an analog discovery 3! Oh, wouldn't it be great if our software worked with those as well? Let's see. Just need a different cable. These guys use USB-C. Plug it into the same board. Finish. Analog digital 3. Start. Look at that, it works! Future-proofing as well.
This thing saves me so much time. Oh my god, I used to be testing these things for like hours and hours on end. I had to do like 100 of them last season, and it took me so long. With this, it's just a breeze. It takes me like 2 minutes to do one of these. It's incredible. I don't know how the guys made it. The tutorial, it's perfect. It's succinct, it's to the point. These status LEDs, they tell me exactly what's going on, so I know if anything is going wrong. And not to mention all of the error reporting it does. The errors are beautiful on this thing. If I do anything wrong, it tells me immediately. The UI is clean and simple. It does exactly what it needs to do, and it saves me hours.
Give me that. This thing, it does have some shortcomings though. We didn't achieve all of the goals that we set out to do initially. Our project scope included also doing validation of digital multimeters. However, we found that that would have been too much scope to really improve quality of life along with time spent doing validation. We might have needed computer vision to read the numbers on the multimeter and some sort of mechanical system to switch the modes. Additionally, you need to install drivers on some machines to get the Arduino working properly. And lastly, you're limited to one board per computer, meaning that you can only calibrate one device at a time unless you have multiple computers set up. Hey.
Are you kidding me? This board is full of potential.
Well, there's many things we can do. First of all, we could introduce a Docker containerization for this board, and this will allow us essentially to run multiple calibrations on a single computer. The second thing we could do is to essentially integrate a digital multimeter on this calibration board, and this will remove the need to connect multiple cables to a computer, because otherwise this might be a major hassle for the end user. The third thing we might do is to essentially remove this serial insertion 4 socket, because we could easily replace this by a socket specifically designed for the analog discovery 2 and 3. The fourth thing we could do is to improve the case of this semi-automated component tester board, because otherwise, if our end client touches any of the electrical circuits here, due to electrostatic discharge, or perhaps due to humidity or any other environmental factors, they might damage this board that we spent so much time and so much care designing. Finally, another thing that we might do is to essentially make this board standalone and essentially allow clients to just connect the 82 and remove the need for them to connect it to a computer. We could achieve this perhaps by integrating a Raspberry Pi 3 that simulates and runs the waveforms and also the PiWin Auto application and performs the calibration. Perhaps we could also show, in that case, the calibration process through LEDs, and essentially this will remove the need for the clients to essentially connect this to a computer, and it will probably lead to a much better system.
It's done. It's calibrated. The final one. They're all done. I can see my kids. Yes! Yes!